Hi everybody, today we got an interesting question. It was asked for MIT admission exam sometime in the year 1869. Now let me write the question down. The perpendicular dropped from the vertex of the right angle upon the hypotenuse divides it into two segments of 9 and 16 feet respectively. Find the length of the perpendicular and the two legs of the triangle. Right now, there are other variations to solve this question, which is already featured in the video section. You can search and find that out, but the approach that I would be employing here is different from the approaches that are existing, right? So having mentioned this, we got a triangle. So let me draw the triangle. Okay, so the perpendicular dropped from the vertex of the right angle. So you have a perpendicular that is being dropped to the hypotenuse. So once you say hypotenuse, we are talking exactly about a right angle triangle, right? So from the right angle, so this is a right angle here. From here, you are hitting here, right? You are hitting the hypotenuse. So that is an important point. So if you hit the hypotenuse, this is going to be 90 degree. Right? That's understood. So if this is 90, naturally the other end would also be 90 degrees. So we are also looking at two triangles, two right triangles embedded inside here. So what I wish to do, we would like to first mention the points. It divides it into two segments of 9 and 16 respectively, right? 16 feet. So this is going to be 9 and this is going to be 16, right? So we are expected to find the length of this perpendicular. Now what I wish to do is, I would like to name these unknowns. So we will have to know what is this. So let me just mention it here. Let this be x and let this be some y. Okay, some x, some y, and let this be z. Right? So we have to find x, y, and z. That's the idea. And this is 90 degree. Now, since this is 90 degrees, this entire triangle is 90 degree, I can actually write this as x squared positive y squared is equal to 9 plus 16, that's 25 squared, right? So this is the first equation I have got. Now having got that equation, now just observe this particular triangle, right? Now if I were to observe this particular triangle, I can actually get, this is actually 90, right? This is 90 degrees because the perpendicular is basically hitting it, right? From here it hits and makes here 90. So this should be 90 degrees. Now if this is 90 degrees, so we are looking at a right triangle here. Now if I were to take this to be the two other sides, and this to be the hypotenuse for this triangle, then I can write z squared positive 9 squared is equal to x squared, right? I can do that. Now let's consider the other right triangles. So this is 90 degrees, right? So if we were to consider this, these two sides can be summed up with the other side being the hypotenuse. This side is going to be the hypotenuse. So this is going to be z squared positive 16 squared is equal to y squared. So I've got equation 1, equation 2, equation 3. So I need to solve these three equations. So what I wish to do is I would like to consider equation 2 and 3, right? 2 and 3. So what would that be? Equation 2 is z squared positive 9 squared is equal to x squared, and z squared positive 16 squared is equal to y squared. So if we were to subtract them, change the sign, change the sign, change the sign, I can clearly cancel the z squareds, right? And what do I get? If I were to cancel the z squared, I would get 9 squared negative 16 squared is equal to x squared negative y squared, which is 4. So now I would be consider 1 and 4. So what is 1? 1 is x squared positive y squared is equal to 25 squared, and 4 is x squared negative y squared is equal to 9 squared negative 16 squared. Now if I were to add them, this is going to get cancelled, right? And you got 2 times x squared is equal to 25 squared, that's 625, positive 9 squared is 81, and 16 squared is 256, right? So let's add them up and find out. So 625 added with 81 is going to be 610 706, subtract 256, so 0, 10 I get a 5, and then this is 6, I get 450. So this is going to be 2 times x squared is equal to 450. So x squared is equal to 2 times 2 times 5. So x squared is equal to 225. So therefore x is equal to root of 225, which is equal to plus or minus 15. But I would take x to be equal to positive 15. Right? I'm taking x to be equal to positive 15. If I were to take x to be as positive 15, then we will have to find the value of y. So what would y be here? So I can clearly substitute over here, right? X is equal to, so let me substitute the value. Put x is equal to 15 in 1. So what is 1? 1 is x squared positive y squared is equal to 25 squared. 15 squared is 225, positive y squared is equal to 625. So therefore y squared is 625 minus 225. So what is that? 625 minus 225, 0, 0, and I get 4. So y squared is equal to 400. So y is equal to 20, right? So y is equal to 20 and x is equal to 15. So now the main thing is to find the value for this height, okay, z. So what I'm going to do, I'm going to use 3. Alright, so using 3. So what is 3? 3 is actually z squared positive 16 squared is equal to y squared. So y squared is going to be 400 here. So this is 400, negative 16 squared is 256. So let me subtract that. 400, 256, 10. I get a 4, this is 9, I get a 4, this is 3, 144. So therefore z squared is equal to 144 and z is equal to 12. So the value of z is 12. So let me place the value. Z is equal to 12, x is equal to 15 and y is equal to 20. So that is the end of this question. Of course, if you want, I can also show you another method.